If you want to understand the true nature of the universe, you must stop looking at the night sky as a peaceful painting. You need to look at it the way a forensic investigator looks at a crime scene. When a detective walks into a room, they don't just see a broken window or a stain on the wall, they see the kinetic aftermath of violence. They read the blood spatter to understand the trajectory of the weapon. They look for the hidden fingerprints of the perpetrator. For thousands of years, humanity has looked up at a faint, glowing smudge in the northern constellation of Andromeda, treating it like a beautiful, tranquil piece of celestial art. We called it a cloud. We called it a nebula. We painted it into our mythologies. But modern astrophysics has finally brought a UV light to this cosmic crime scene. That glowing smudge is not a peaceful cloud of gas. It is the undisputed apex predator of our cosmic neighborhood. It is a gluttonous, cannibalistic empire that has spent the last 10 billion years violently tearing apart lesser worlds, leaving a trail of gravitational carnage in its wake. And the most terrifying part of this investigation? We are not just the detectives piecing together its violent past. We are its next meal. Welcome to the dark, predatory reality of the Andromeda Galaxy. To comprehend the terrifying scale of Andromeda, we first have to realize how dangerously we underestimated it. Imagine standing on the shore of a dark ocean, seeing a small, pale fin breaking the surface of the water in the distance. Because it looks small, your brain assumes it is harmless. You might think it is just a strange ripple, or perhaps a tiny fish. This was exactly how humanity treated Andromeda for centuries. Because our eyes are utterly incapable of processing deep space geometry, early astronomers assumed this glowing patch was just a pocket of glowing dust floating gently within the borders of our own Milky Way. It wasn't until the early 20th century, armed with more powerful telescopic glass, that astronomers finally measured the true distance to that pale fin. The mathematical reality hit the scientific community like a physical blow. It wasn't a tiny cloud inside our galaxy. It was an unfathomably massive Leviathan lurking a staggering 2.5 million light-years away in the freezing depths of intergalactic space. To appear that large in our sky from such a mind-numbing distance, it couldn't be a mere cloud. It had to be a monstrous congregation of stars. In an instant, our understanding of the cosmos shattered and expanded. The Milky Way was no longer the entire universe, it was just one island in a dark ocean, and we suddenly realized we were sharing these waters with a monster significantly larger than ourselves. So, what happens when we put this predator on the autopsy table? When NASA's Hubble Space Telescope and other modern observatories stripped away the starlight and mapped the physical anatomy of Andromeda, they uncovered a history of brutal galactic cannibalism. Let's look at the sheer scale of the beast. The Milky Way is a formidable galaxy, boasting anywhere from 100 to 400 billion stars. But Andromeda dwarfs us. It is a sprawling disk containing roughly 1 trillion stars. It stretches across 220,000 light-years of space, acting as the gravitational heavyweight champion of our local group of galaxies. But a predator is defined by its stomach, and Andromeda's gut is filled with the remains of its victims. When astronomers look at the outer edges of the Andromeda Galaxy, they don't find a smooth, orderly edge. Instead, they find what are known as stellar streams. Imagine finding torn shreds of clothing scattered around a lion's den. Stellar streams are exactly that. The most famous is the giant stellar stream, a massive, elongated trail of aging stars stretching hundreds of thousands of light-years away from Andromeda's core. These are the torn, shredded remains of a smaller dwarf galaxy that made the fatal mistake of drifting too close. Andromeda's immense gravity latched onto the smaller galaxy, stretching it out like cosmic taffy, stripping away its outer stars, and devouring its core. Andromeda is currently surrounded by a swarm of these ghostly remnants. Small dwarf galaxies like M32 and M110 orbit closely around it. They look like independent companions, but forensic astrophysics tells a different story. These are half-eaten carcasses. Their outer layers of star-forming gas have already been brutally violently stripped away by Andromeda's gravitational tides. They are dead worlds walking, slowly spiraling inward to their inevitable doom. All of this consumed matter has to go somewhere, and it feeds the darkest organ of the predator, its central supermassive black hole. The black hole at the center of our Milky Way is a relatively modest 4 million times the mass of our Sun. The black hole lurking in the heart of Andromeda? It is an absolute behemoth, estimated to be up to 140 million times the mass of our Sun. It has grown morbidly obese by swallowing the hearts of the galaxies Andromeda has conquered over the eons. But the most shocking discovery about Andromeda's anatomy was made just a few years ago. In 2020, NASA's Project AMIGA mapped the invisible halo of plasma surrounding Andromeda. They discovered that this sphere of superheated gas extends an unbelievable 1.3 to 2 million light-years in nearly every direction. It is a massive, invisible spider's web. And the terrifying truth is, this web is already touching the outer edges of the Milky Way's own gas halo. The two galaxies haven't even collided yet, but their outer atmospheres are already brushing against each other in the dark. This brings us to the most urgent phase of our cosmic investigation. The Leviathan is not just sitting in the dark, digesting its past meals. It is actively hunting. In physics, there is a phenomenon called the Doppler effect. If an artillery shell is whistling through the air directly toward you, the sound waves compress, and the pitch gets intensely higher. Light behaves in the exact same way. Because the universe is expanding, almost every single galaxy we observe in the cosmos is redshifted, meaning their light waves are stretched out as they rush away from us. But when we point our spectrometers at Andromeda, the light is not red. It is blue shifted. The light waves are compressing. The artillery shell is heading directly for our coordinates. Driven by the inescapable chains of mutual gravity, Andromeda is plunging toward the Milky Way at a breathtaking speed of 110 kilometers per second. That is 250,000 miles per hour. At this speed, you could travel from the Earth to the Moon in less than an hour. For the next 4 billion years, the night sky of Earth will slowly transform from a familiar, comforting canopy into an agonizing countdown clock. Right now, Andromeda is a faint smudge. But in 2 billion years, it will look like an ominous, glowing slash of light dominating the night. In 3.7 billion years, Andromeda's massive core will fill the entire sky, an incandescent tidal wave of 1 trillion alien stars bearing down on our home. And then, roughly 4.5 billion years from now, the impact will occur. It will not be a collision of solid objects, it will be a gravitational hurricane. When the two galaxies intersect, the sheer tidal forces will warp both of their beautiful, majestic spiral arms into grotesque, chaotic shapes. The Milky Way's disk will be violently bent. Andromeda will plunge through us, acting like a cosmic slingshot, tossing millions of our native stars completely out of the galaxy into the freezing void of intergalactic space. Yet, here is the greatest paradox of a galactic collision. Despite there being over 1 trillion stars involved in this cosmic car crash, the distances between individual stars are so unimaginably vast that the chances of 2 actual stars colliding head-on are practically zero. It is like firing 2 massive swarms of bees directly at each other across an empty football field. The swarms will pass right through each other without a single insect touching. Our Sun, and whatever is left of our solar system, will likely survive the physical impact. But our address will change forever. The Sun could be hurled to the extreme outer fringes of the new chaotic galaxy, or it could be dragged deep into the lethal, radiation-soaked core, violently orbiting the 2 supermassive black holes as they enter a deadly, spiraling dance of death. Every violent feeding frenzy must eventually come to an end. The gravitational dance between the Milky Way and Andromeda will rage for hundreds of millions of years. They will pass through each other, their gravitational leashes pulling them back together, again and again, until their two supermassive black holes finally merge into one singular, terrifying singularity. When the dust settles, the beautiful, spinning spiral structures of both galaxies will be completely destroyed. In their place, a newly forged supergalaxy will remain an enormous, featureless, elliptical blob of stars that astrophysicists have morbidly nicknamed Milkomeda. But this victory for the Predator is a hollow one. By crashing into the Milky Way, Andromeda will trigger massive shockwaves that ignite hyperactive star formation. The remaining gas clouds in both galaxies will be rapidly exhausted, burning out in a brilliant, final flash of cosmic glory. And then, the food runs out. With all the free-floating hydrogen consumed or scattered, the new Milkomeda Galaxy will completely lose the ability to birth new stars. The Leviathan will have eaten everything in its territory, and it will begin to starve. Fast forward tens of billions of years into the deep future. The bright, massive blue stars of Milkomeda will detonate as supernovae and fade away. The galaxy will be populated only by ancient, dying red dwarfs. Slowly, methodically, over trillions of years, even these embers will suffocate. The Predator will age into an unrecognizable, freezing graveyard of black dwarfs, neutron stars, and silent black holes. Because the expansion of the universe is accelerating, all other galaxies outside our local group will eventually be pushed so far away that their light will never reach us again. Milkomeda will be the only object left in our observable universe. The apex predator will be entirely alone in an infinite, pitch-black void, dying of old age. When you look at the raw, violent machinery of the cosmos, it is easy to feel like an insignificant victim, waiting for the clock to run out. We are sitting in the crosshairs of a trillion-star behemoth that is hurtling toward us at 250,000 miles per hour. But I invite you to look at it differently. The dinosaurs never knew what hit them. The dwarf galaxies that Andromeda shredded billions of years ago had no telescopes to comprehend their own demise. But we do. We possess the mathematics, the glass, and the intellect to look into the deep dark, identify the apex predator, and calculate its exact trajectory. We are the only prey in the known universe that has the privilege of understanding the majesty of our own ultimate destruction. We get to watch the hunt unfold. Knowing that 1 trillion alien stars are currently speeding toward our solar system, does it make you feel anxious, or does it make the universe feel that much more magnificent? I want to read your perspective on our cosmic collision, so drop your thoughts in the comments below. If you want to continue mapping the crime scenes of the cosmos and understanding the terrifying physics that govern our reality, hit that subscribe button and turn on the bell. The universe is a dangerous, beautiful place, and we have a lot more investigating to do. Until next time, keep your eyes on the sky.